Good morning, everyone. There's a poll up on the screen right now asking how many people are in the room with you. We do this one every once in a while just to get better numbers as far as the attendees, because we do allow for people to log into conference rooms and kind of share the experience here. So if you're just logging in, you should see a poll up on the screen, and we'll begin the webinar in a second. It looks like an overwhelming majority of the folks are in the room by themselves, 87%. 11% of the people have one person in the room with them. 2% of the people have 4 in the room with them, and there's no one that has 5 or more. But we have a handful of folks in there. Give it another second here, then I'll close the poll and we can begin our webinar.
Okay, sounds good.
All right, I'm going to go ahead and close the poll. You can share that with the audience in case anybody was curious. And I believe I am sharing my screen, yes? No, I'm not. All right, just to double check here, Dennis, you're able to see the Safety Academy page?
Yes, it looks fine.
All right, so it's a quick reminder like we do every week. The website is tampabaytrafficsafety.com. Under the Education tab, there is a link to the Safety Academy. This is the place for information regarding the Safety Academy. The upcoming webinars are here, all the topics that are upcoming. There are links for registration here if you haven't already registered, and this is the location as well where the presentations and the recordings of the past webinars are posted. These go back to 2013 when we started this. Under the resources as well, it's at the bottom, there is the PDH request form, although you'll notice that the PDH request form has also been included as a handout to this webinar, so you should be able to download it directly if you're present right now. With that, I will transfer it over to Dennis for his introduction.
Good morning. This is Dennis Falloon. I want to welcome all the attendees that are new and all those that have attended prior webinars. And I'm the District 7 Safety Academy Coordinator and District 7 Consultant. And this is the 6th webinar topic for the 2015 Safety Academy. And today's topic is roadway lighting for safety, and that will be presented today by Rochelle Garrett, PE, and Traffic Design Engineer in District 7. But before she begins, let me just talk through my little introduction I give to every webinar, just so you know what's going on, if there's any changes. As you know, these webinars have been set up to provide information regarding safety-related issues to enhance your local safety programs. And that's the main purpose and function of the Academy. This began in January 28, 2015, the first webinar for this year, and they usually start, they run between 10 and 12. We start about 10:05. They usually on Wednesdays. It will end the last one on December 16th, which is a Wednesday. And the minimum time the webinars go for is usually an hour, but no more than 2, and it depends on the complexity of the issue. And as Anthony previously showed you, these are the links to register, and also you can go check out the previous webinars, which are on that same page he showed you. And as I mentioned today, we're doing a roadway lighting for safety webinar, and as you can see, there's 6 additional ones remaining, and another one may be added, but we're still in the process of working that one into the schedule. So just stay tuned, and I'll keep you informed about that. Then also the CPM credit, there's some, I'm working on that with Stephen Benson on some stuff. Those get posted out there through their webpage, the planning webpage, so that'll be taken care of through that. And also I just want to mention too, you get some notices, and so you get a notice each month, and about 2 weeks before the webinar, and then 2 days before the webinar, and 2 hours than before the webinar. So you get a number of notices about the meeting. Also wanted to mention about the PDHs for Florida's PEs. This is handled by Larry Hagan, and you will email it to him he's the PDH coordinator, or you can fax it to him. He's got a number there, and you get one PDH hour for this course. You get a certificate. And this is the link that Anthony showed earlier. It's on that same page. And this is my contact information. And it's in a number of notices, too, that you receive. So if you have any questions, please feel free to contact me. And with this, Anthony, we can turn it over to Rochelle and let her begin her webinar. Thank you.
All right. We'll set Rochelle as the presenter here. As always, we try to keep this fairly informal, so if you have any questions, I'll be monitoring the chat, and we'll do our best to answer them throughout the presentation. So please type questions into the chats.
Yeah, hit that. Yeah. Okay. Can everybody see the screen?
Yes.
Okay. Thank you. I'm Rochelle Garrett. I've been the District 7 Traffic Design Engineer for about 7 years now. I've worked in traffic engineering for about 28 years now in the public and in the private sectors. My co-presenter is Bill Parman. He has been with Florida DOT about a year now. Prior to that, he instructed me to say this now, 30-plus years experience in both the private and public sectors, and a lot with Virginia DOT. In addition to Bill, I have Bruce Miller here. He is a lead lighting designer with Lochner and is a graduate electrical engineer. And he's here just in case we have any questions that he may be privy to more knowledge than me. So at that, I will pass the torch to Bill Parman to get started.
Good morning, everyone, and welcome to the presentation. I'll start kind of light here with a little brief history on the light side. A little brief history of lighting. The first use of street lighting is believed to have been in ancient Greece around the 4th century in the city of Antioch. The next significant use was in Cordoba in the Arab Empire around the 9th and 10th century, then in London around 1417. It was introduced in the U.S. by Benjamin Franklin in Philadelphia using candles and lanterns, which he fashioned to have 4 separate glass sides. That's kind of a unique adaptation by him, because before that it was like the globe or the cover broke, you'd lose the whole thing. But with him introducing that, you could lose one side and still not lose the whole device there. William Murdoch, the next big step, introduced gas lighting to London in 1792, and the U.S. soon followed with gas lighting in Newport, Rhode Island around 1803. It spread throughout the country and is still in use today in a few locations. Electric light bulbs for street lamps were developed soon after Edison's invention of the incandescent bulb and the spread of electricity in the country. The first city to use electric lights was Wabash, Indiana in 1880, although this is disputed because the inventor, Charles Brush, was from Cleveland and did a lot of his work and testing and stuff there. Incandescent and fluorescent street lighting spread rapidly in the 1930s and 1940s in the country with the popularity of the automobile, replacing most of these fire-based street lights. Going on to more modern times, in 1957, Westinghouse introduced the Cobra head. GE, its main competitor, followed later with its own version. Introduced in 1948, mercury vapor was the first major improvement to the incandescent streetlight. High-pressure sodium was invented in 1970 and has been in wide use since the 1980s. Light-emitting diode, LED, was not introduced until more recently, around the mid-2000s, and is FDOT preferred lighting on new systems. Okay, on to the purpose of roadway lighting. It is primarily we want to reduce the nighttime vehicle crashes, injuries, and fatalities, and also reduce nighttime pedestrian and bicycle crashes, injuries, and fatalities. Our strategy has been lighting focused on warranted roadway lighting and signalized intersections with higher pedestrian volumes and crashes. Numerous studies have shown that nighttime fatal crashes have been reduced up to 60% with the installation of roadway lighting. There are many of these studies, and I cite a few right here. Elvik and Va in 2004 reviewed 38 studies before and after roadway lighting was installed and found 64% reduction of fatal crashes, 28% reduction, and 17% reduction in property damage only crashes after lighting was installed. Per Olwanek, 2009, used various study methods and literature review and documented the usefulness of lighting as a countermeasure and found a mean 28% reduction in injury crashes, 60% reduction in fatal crashes, a 45% reduction in injury crashes involving pedestrians, 35% reduction in crashes at rural intersections, and also a 50% reduction in injury crashes on freeways. Yep, the last one there up there was Minnesota Local Road Research Board, 2006. They compared rural intersections before and after roadway lighting was installed and found that 44% of the intersections showed reduction in nighttime crashes. I went too far. Take it back. Sorry. Great. There you go. Okay, there. Highway safety improvements with the highest cost-benefit ratios. I have a list here from the, there's 20 in the list, but there were the top 10 here. And as you can see, illumination is number one. History and that is the case. Some of the others up there, upgrade median barrier, traffic signs improvements, installation, relocate, or install breakaway utility poles, remove obstacles, new traffic signals, impact attenuators, new median barriers, and so on. So forth down through there. The positive impacts. We want to improve the view of roadway geometry and adjacent environment, increase the sight distance to improve response to hazards and decision points, eliminate dark spots and improve the mutual view of motorists and pedestrians, provide clearer view during police, emergency, construction, and maintenance activities or events. Continuing on with this, well-designed lighting helps with the adjustment to avoid the effects of glare. And roadway lighting helps the eye adapt to increased levels of luminance. Also, older drivers and pedestrians benefit from increased lighting levels. I've lost my... There are also negative impacts with the installation of roadway lighting that you have to look out for. They're negative. The main negative is light trespass, which can consist of glare, often referred to as veiling luminance, spill light, light that falls outside the area intended to be lit, and sky glow, light that is reflected up into the atmosphere from the source, road, or other surfaces. In this illustration, you can see that the area to be lit there is in yellow, which includes your roadway area from shoulder to shoulder, or if you have sidewalks, it could be sidewalk to sidewalk and so forth like that. Light that goes outside of that area in yellow is light trespass and can be glare, the spill light, and the upward reflected light, into the atmosphere that it contributes to sky glow. Here's some examples of light trespass. On the left, sky glow, and on the right there, glare, which can also come from sources outside the roadway and the adjacent properties and so forth. Stadium, if you're near a car dealer or something, one of the ones that are famous for that. Lighting justification. Warrant analysis required for FDOT projects. Follow the guidance outlined in the Manual on Uniform Traffic Studies on Chapter 15, MUD. It requires a letter of acceptance or a memo of understanding, MOU, from the local agency, local maintaining agency, yeah. Also, safety analysis or study showing that lighting would be a cost-effective alternative or countermeasure using the AASHTO or HSM Highway Safety Manual predictive or other methodology. Meeting the warrants, though, does not guarantee, it doesn't require that lighting must be installed. Traffic operations here in the District 7 usually perform a study to determine if roadway lighting is warranted for FDOT projects. And also, you want to document the crash frequency and severity so that lighting, geometric, or operational improvements can be quantified. A template for a letter of acceptance or new lighting is available from traffic design or a maintenance office as well. Also, project criteria document showing that FDOT design criteria will be used and met. Okay. Continuing on in lighting justification, in step 1, you look and follow the AASHTO warrants, which considers traffic volumes, your average daily traffic, your ratio of night to day crashes, and you should be looking at a 2.0 or greater. You also want to see if there's local government participation in the cost of the lighting, and then, like we mentioned before, that local government agreements are in effect and they're aware of it. Kind of as a baseline, you want to look at 25% or more or greater for nighttime crashes. Step 2, determine if the project is justified based upon its benefit-cost ratio. If the benefit-cost ratio is 1.0 or greater, then lighting is justified on high crash locations. But it's much preferred to use 2.0 for all locations, because if you have a project where you're really close to the 1.0, say like at 1.1 or 1.2, and you're starting early on in the project to look at this, and the costs and so forth may change as the project goes along, and your ratio could drop below. And then if you have federal funds, those could be in danger. They'll be looking to maybe even get those back if your ratio drops below that 1.0. So always try and have it up towards the 2.0 or more. And here's a map showing the corridors with 25% or greater nighttime crashes, which can be used to identify locations. And this is ongoing and will be updated, here and there and occasionally. This is also available through our District 7 Traffic Operations Safety Office. And if you have access to the SharePoint, the link there and location is on the screen there for you to look at.
Yes. There you go.
Okay. Having a little bit of trouble with the clicker here, clicking over. The predictive method, or from the Highway Safety Manual, HSM, you have using this, I've got it, methodology. Say you have a project that is on a segment, and you're looking at it. You would first quantify the crash data and so forth, and then maybe looking at that segment, you might want to say, well, if I light the whole corridor, what cost benefit will I get from lighting the whole corridor? And then you might also look at another alternative, looking at, say, just lighting the intersections, or if you're on a limited access, the interchanges, and so you can compare different alternatives and determine your cost benefit. And you can also use multiple factors in that, and relate in some other ones like rumble striping or something to compare multiple things. Other important things to consider in lighting justification is it is FDOT policy to light all interchange. And you have to consider lighting in adjacent areas, the presence of crosswalks or medians can have a big impact, and also constructability and feasibility. That mainly involves right-of-way and utility issue. Are there big right-of-way issues? Do you have enough right-of-way? Are there utility poles in the way of where you want on one side or where you want to put the lighting? You can maybe consider whether you could use those poles or not, depending on what they are and who's the jurisdiction you're working in. Underground utilities can be a big issue too for putting the poles in the right location. Lighting analysis. These are the software packages available. It's not a comprehensive list, but they include AGI 32, Visual, Cala, which is Hall of Fame's proprietary software, and Aladdin, which is done by GE. Like I say, there may be other packages available, and the department does not require a specific software. The lighting analysis report and some of the elements I have up here. These can vary. This is not, set in stone. You can have different names for some of these. But first, you'd have a project overview or description, stating the location of your project, and then the purpose, and specify any lighting criteria that may have been, provided to you, from the agency or the department and so forth. You want to document your methodology for selection. And then the procedure. Make sure that the project is designed to FDOT standards and PPM and the Plans Preparation Manual, referencing that as needed. And then in your analysis, document the software tool that you used and the alternatives, parameters, describe the luminaires, LED for new systems, the wattage, the mounting height, cost comparisons, and pole spacings. Also, you want to include the analysis here, the design criteria, the photometric analysis, and lighting calculations. After that, going through your whole analysis, then you would document your and write down your recommendations and comparing the alternatives and so forth, and making the best lighting selection. And your appendices usually would follow that after that with lighting and voltage drop calculations and other data that you want to include in the report. Here is an example of lighting analysis. I don't know if you can read those numbers. They're hard to read, but they're real small. This one, obviously, is at an intersection, includes the crosswalks and so forth there. In this case, the average here was 2.7-foot candles. The max was 5.1-foot candles. The minimum was 0.9-foot candles. And the max-min ratio was 5.7 to 1. The average to min ratio was 3.0 to 1. And the average to max ratio was 0.5 to 1. Okay. Then in your selection, the other factors to include were that the one you're selecting meets or exceeds the standards or specifications and has the proper photometric performance. You might want to look at the durability and the aesthetics of it and the availability of the one system you're recommending. There are also maintenance requirements you want to consider, and your cost, both initial and operating, more long-term costs and maintenance costs. It's also key to remember to get your lighting analysis report approved before beginning the design, or you may be at risk. Now with this,
there was a question in the
okay.
There's a question in the chat regarding LED lighting. If you've got a second, that they're asking if FDOT is planning to retrofit existing corridors that have high pressure sodium lighting with LED. The cost savings are pretty high. If you can talk about that, or if you're talking about it later in the presentation, then save it for then.
I think we are going to get into that a little bit, but yes, we are planning to retrofit as we
upgrade.
Upgrade.
Retrofitting pole in place would depend on the fixture. So we have been very successful in the city of Tampa. TECO upgraded Hillsborough Avenue from high pressure sodium to LED. And if you drive out there, you will see what a good installation it is and how bright it is now. Oftentimes, a one-to-one retrofit, that is the dream. And I hope that it will happen, but we haven't seen that one-to-one product. Have you?
There is a product that approaches the high-pressure sodium, but sometimes it's not one-to-one because of either mounting height. Because the LED performs better at a lower mounting height than the high-pressure sodiums. But, high-pressure sodiums are mounted at 45 to 50 feet, and that's generally the range where the LED starts to not meet the same criteria.
So we are open to it, and at the rate they're coming out with some good products, hopefully we'll see it soon.
Okay. With that, now I'm going to turn it over to Rochelle Garrett for the rest of the presentation, where she's going to get into some design and design issues and challenges.
Thank you, Bill. Okay, here we go. We have many design standards to use for guidance when designing lighting plans. Valuable resources are available from the DOT, FHWA, AASHTO, IESNA, and the local agencies. Items from two valuable resources from the DOT that I'm going to discuss today are the design standards and the PPM. The department has developed standards for conventional lighting, high mast lighting, sign lighting, service point details, and general notes. These are all shown on indexes 17500 to 17515 in the DOT design standard. The example shown is an aluminum light pole standard for conventional lighting. The standard provides details for 40, 45, and 50-foot luminaire mounting heights on poles mounted either at grade or on fills up to 25 feet, all of which accommodate fixture arm lengths of 8, 10, 12, and 15 feet. Standard aluminum light poles have been designed for 110, 130, and 150 miles per hour design wind speeds. District 7 is located within 130 mile per hour wind speed zone. This is a typical layout for lighting for a staggered installation and a median installation. Just so you know, median lighting is not allowed on the state system unless it's shielded or barrier mounted. More typical layouts are illustrated on this slide. This is for a one-side or opposite pole installation. The one-sided installation may be necessary when there are utility conflicts on the other side of the road or to lessen the probability of poles being struck on the outside of a horizontal curve. This is a typical intersection lighting plan. The luminaires are mounted on the signal poles, and they're also mounted in advance of the crosswalk locations. This is to provide the maximum lighting for a pedestrian. This example has a total of 12 luminaires. This is a lot more than what we have done in the past. The clear zone requirements for light poles are different from other fixed objects located on the roadway shoulder due to the breakaway design of the light poles. Guidance for this is located in Chapter 2 of the PPM. For an urban curb and gutter roadway, the minimum distance from the face of the curb to the light pole is 4 feet. And this is to the face of the light pole, not the center. For other roadways, the minimum distance from the edge of the travel lane is 20 feet or 14 feet from the edge of the auxiliary lane. Please remember that bike lanes are considered a travel lane. All poles are breakaway unless they're barrier mounted or shielded. The department has chosen to use the illuminance technique for all lighting design. Illuminance is a measure of how much light illuminates the surface. And just so you know, a foot candle is the illuminance cast on a surface by a 1 candela source 1 foot away. This is Table 7.3.1 from the PPM, and it addresses the illumination levels that are required on DOT roads. In general, most state roads require 1.5 foot candles of average lighting, an average to minimum uniformity ratio of 4:1 or less, a max to min ratio of 10:1 or less, and a veiling luminance ratio of 0.3:1 or less. These are standard levels, but should be increased to maintain an acceptable uniformity ratio. Now, just as an aside, I have had designers tell me they meet the absolute minimum lighting levels. They hit 10:1, and they consider the system perfect. What they have designed is a very cost-effective system. But what we want is a well-lit system. So this may mean we have more poles than what we did in the past. So what happens when our uniformity ratios exceed 4:1 for the average to min or 10:1 for the max to min? Well, the corridors will have dark and bright spots as shown. Our goal is to have an even distribution of light.
Rochelle, regarding those light and dark spots, there's a question in the chat. If you have a very large intersection, do you still have to meet the lighting standards and uniformity in the middle of it? Like these multi-lane with dual lefts, dual rights. Can the center be dark, or do you need to somehow cast light out there?
Our goal is to meet the standards. It is possible there are corridors or intersections that we cannot. And if that happens, then we will do the best we can do. But first, we have to show that it isn't possible.
And there's also a comment about FHWA research that's coming out regarding the location of the lighting for pedestrians. FHWA is recommending the lighting on the approach side for pedestrians be installed for best visibility. Your little diagram of sort of like an ideal intersection, have them evenly spaced around. What kind of adjustments are made, for different conditions, especially for pedestrians, to that?
Well, that was a typical, and of course, when you do your calculations, and we'll look at what we got. We always have to adjust pole locations based on real-life conditions. Is there anything you want to add?
That typical intersection, it had poles along the approach as well. It just wasn't sitting at the intersection. So that would have helped illuminate the pedestrians that was going to enter into the crosswalks.
Yeah, they were before the crosswalk on both sides. It was a lot of lights for one intersection. Did we answer it?
Don't chime in the chat again, I guess, if they have a follow-up. I feel like you did.
Okay, so we'll move on to this slide. So, where are we going? That's always interesting. So there are proposed changes to Chapter 7, to the methodology and to the intersection criteria. Some of the methodology changes are the analysis zones, the photometric calculations, and the lighting criteria. Starting with our analysis zones, these will be clearly outlined for urban and rural typical sections in the PPM. For a divided roadway segment, the zone will include the roadway surface and the adjacent sidewalk location. Illumination of the grass median is not going to be measured. For an undivided roadway, the zone will include all of the roadway surface, the turning lanes, the paved medians, and the adjacent sidewalk. For signalized intersections, the zone will include the roadway surface from the stop bars to the back of the sidewalk. The proposed changes to the PPM include defining the photometric calculation grid. When calculating the photometrics of a roadway corridor, the point calculations will be 15 feet longitudinally along the roadway and 5 feet transversely across the roadway. When calculating the photometrics of an intersection, the point calculations will be 5 feet longitudinally and 5 feet transversely. These will be defined in the PPM. This is a new proposed table. And right now, the DOT requires 1.5 foot candles for a roadway corridor and the signalized intersections. The proposed chart for intersections with high pedestrian traffic will increase the average horizontal foot candles from 1.5 to 3.0. In addition, a new value is added for vertical foot candles. The definition for a high pedestrian location is still under review, as is this chart, I guess, but will likely include intersections in the central business district, intersections adjacent to college campuses, hospitals, transit stations, and locations with high nighttime pedestrian crashes. So what is vertical illuminance? Our normal method is to calculate the horizontal illuminance of a roadway surface, but vertical illuminance is calculated at 1.5 meters or about 5 feet above the ground. So visualize the light meter 5 feet above the ground, facing toward a driver from the pedestrian's position. This driver is assumed to be located at the calculated stopping sight distance away from the crosswalk location. We will be calculating the vertical illuminance for the near side crosswalk, the crosswalk for the right turn movement, and the left turn movement. You do this for each approach. Oops. What did I do? Okay, do you see the dark line in the closest crosswalk? This is a location for the first vertical illuminance calculation. See the dark line in the crosswalk on the right-hand side. Calculate the vertical illuminance for this location. See the dark line in the crosswalk on the left-hand side. Calculate the vertical illuminance for this location. So the question is, are you done? No! You have to do this process for each approach. And if the question is, will you have to get more hours, I would say the answer is yes. But I haven't figured that amount out yet. I guess that's one of my lighting challenges. So we do have a lot of lighting challenges. We have to get the intersection photometrics right. We have to increase our lighting levels, but when we do that, we may have to add transition lighting. So our problems just continue. Some other challenges. If you're working in a beach community, we've provided a link to maps that will help you identify areas that should not be illuminated due to sea turtle nesting. These are areas where lighting is not appropriate. But in areas with high pedestrian activity, illumination can have benefits in crash reduction. We have a 1.5-foot candle standard, but as discussed earlier in the earlier slides, this will be increasing at intersections with high pedestrian volumes or at mid-block crossings. Please be cognizant of the neighborhood around the corridor. Intersection or interchange being lit. Lighting can disrupt the circadian rhythms, and a department may receive complaints about excessive lighting, especially high-mass lighting near homes. We're going to see more about this in a future slide. When designing a lighting project, many items must be considered. These include clear zone requirements and overhead and underground utilities. Remember, OSHA has strict rules for worker safety, and these are not the same thing as the National Electric Code. Options do exist for poles or equipment that are within the minimum OSHA clearance of an electrical line. Our first choice is always to minimize impacts to utilities, but in some cases, it may be necessary to consider de-energizing and grounding the power lines, relocation, or raising of overhead conflicts. Other concerns include environmental issues. Airports require permits for structures within their glide paths, even when this is located on our right-of-way. Railroad companies also have a permit process, a difficult permit process. FDOT already has maintenance agreements with all maintaining agencies within District 7. However, when the system is being expanded, we do require a letter of acceptance from the local agency. This is so it's very clear that they understand we're adding to the system that they have to maintain. We want this included in the project design documentation. We do have a template, and you can either get this from my office or from John Foley in maintenance. So here's just a picture of some challenges with overhead lines. The OSHA guidance for the minimum distance from power lines is located on the chart. So we've kind of identified the overhead lines. I don't know if these are transmission or distribution, but underneath that, we have the neutral line, and then below that, the other utilities. So depending on the voltage, that distance, it's a radial distance that we need to be from a power line to meet the OSHA guidance for worker safety. Okay, here's just some quick pictures of various situations throughout our district. So in this one, location matters. Stay out of the bottom of a ditch. Our maintaining agencies get very upset when the bottom of a pole is standing in a pool of water. So just keep that in mind. Here's an example of a sidewalk project, an easy sidewalk project that buried the bottom of the existing light poles. In this present condition, the breakaway features do not function, and the maintaining agency can't actually access the bottom of the pole. They tried to retrofit this by putting in that box right next to it, but it really wasn't an acceptable condition. So one way to fix this is in this picture. It does reveal the bottom of the pole. It still kind of has some issues with the sidewalk. Here's a better fix. In this particular case, the existing light system was old, and they did not have the pull boxes that are now standard. So we actually moved the pole to where it's shown now. It originally was where the pull box is. So a new foundation was installed, the pole relocated to the new foundation. Where the old pole had been with the old-timey screw-type foundation, a pull box was installed, and then we were able to connect it using the standard Intex 17511 with the breakaway, fuse holders, and surge arresters. This is an example of a new multi-use path that was in direct conflict with an existing high-mast light pole. Luckily for the designer of the path, the existing light pole was in such poor condition it had to be replaced. So a compromise was to adjust the path slightly. You can see there's a kink, and to move the pole, and to adjust the ditch to create a flat spot above the expected water line. Remember, I said I'd come back to something? There was a nearby residential area where a homeowner complained about too much lighting. Specifically, he said, I can read a book in my backyard. At night, sorry, he could do that in the day, but he could do it at night. So in that case, we were very fortunate, but we got cutoff shades. So this reduced the lighting off right away. So it's kind of hard to see, but that the black piece next by the luminaire are the shields. And it did help. He hasn't called me back.
Rochelle,
okay,
some
right
of these challenges,
now,
there's a question in the chat with some of these challenges and things that are happening with the lighting. After the lighting is installed, what procedures are taken care of to make sure that the proper lighting is provided? Is it just it's designed properly and then it's installed, or do you guys go back after the fact and actually evaluate the levels and do some sort of post-installation analysis?
Traditionally, we have not. However, we are understanding that there could be problems on a corridor that is lit, and that is something that you have been working with and may want to describe the cutter vehicle that has been driving corridors and determining what the actual light levels are.
Sure. I can. I don't want to derail your train of thought too much, so I'll save it maybe for the Q&A at the end. But I'll definitely chime in. Do you want me to go ahead and derail?
Yes, derail me.
Okay. Sure. Well, the Center for Urban Transportation Research developed. Here, let me make myself the presenter real quick, since let's really derail this thing. I actually had the presentation up on my screen in case this question was asked. Which screen are we seeing here? you're able to see the chat window. Okay, let me put this over here. The Center for Urban Transportation Research over at USF developed a vehicle that has these light meters on them, and they drive the roads with these, and they're able to record the left side and right side of each lane. They drive it each way, and it does a recording every, I believe, 5 feet. And they have a pretty sophisticated, this is, the points go along, and they record everything along the levels. They have a pretty sophisticated thing when they're driving. It's, one person's driving, there's another person that's typing all these notes, so they take into account spillover lighting from adjacent intersections, from parking lots, if there's trees in the way, like if there's oncoming vehicles. So there's all this, there's a lot more metadata attached to this besides just the lighting levels. And what that looks like when you plot it is a histogram, a heat map of the lighting data, and it allows us to do a lot of really neat things. We correlate that data, for example, with some maps that we developed for the district. You showed a smaller version of something like this earlier in your presentation that is a nighttime percentage map. So we take that cutter lighting data and know whether or not the lighting is above or below standard, and we look at the percentage of nighttime crashes along each of the roadways. This is along half-mile segments. And with that information, along with the lighting data, that we've done the histograms of, and we've done all the analysis of that, when you zoom into a particular intersection, you identify locations that have crashes, and you're able to see, well, it's dark in this location. These are the actual lighting points from the cutter data. It's dark in this quadrant. It's bright in this quadrant. It's darker in this one. It's brighter in this one. When you go out in the field and actually see what's there, you see that in the bright quadrant, you have lighting. In the brighter location, you can't see it back here, but there's lighting here. There isn't at this location. So one of the things that Traffic Ops has done is to go out and identify locations where there's an existing utility pole, for example, was this particular task that we helped on. This quadrant here, the northeast quadrant, there is a utility pole that you can see here in the existing condition diagram. And you can see the lighting, it's bright here and here. That's where the street lights are. That's this light and this light right here that is providing that illumination. And there are crashes at this intersection. It's 33% nighttime crashes. So there is, a new light that's going to be installed in this quadrant to improve that. So, there's a lot that we can do with the crash data and the actual lighting. But yeah, the short of it is that absolutely there is a, the Center for Urban Transportation, big props to them. It's a cool little tool that they developed. And they've collected lighting along, 400 miles. In District 7, it's a lot of data that they've collected, and we've been analyzing that and figuring out. We've done some before and afters. There were some lighting corridors that had high-pressure sodium lights, and they drove that corridor, and then they upgraded it to LED lighting, and they drove the corridor again, and we were able to see, the differences and the numbers and how the data changed. So, in a little while, we'll do a before and after study there to see if the nighttime crashes went down when the existing lighting was improved. That's pretty neat. Let me switch this back over to you. I don't know if hopefully that answers the question, showing off some of the cool things that Ops does as a proactive approach to it.
Okay, back to me. I had a recent challenge on several intersections within our district that had a high number of nighttime pedestrian crashes. They were within the top 20 of the state. So one of them is this one right here, Fowler and 15th. So the question was how to illuminate this and illuminate it quickly. The corridor theoretically is lit, but maybe not lit well enough. So in this case, we have power company lighting on one of their poles. So always remember that's an option. This is the same intersection. Another option is the power company installs a luminaire on our pole. as you can see in this particular case, they are providing service overhead. And when this signal pole gets replaced with a mast arm, which it is, we actually provided a stub off the top of our mast arm. You know, it extends another 5 or 6 feet so that when we install our mast arm, it still won't have lighting on it, but the power companies agreed to attach their luminaire on that extended stub out from the mast arm. So anyway, and they will serve it overhead. There again, it won't be a very beautiful installation, but it will provide light. This is the same location at night. We have it illuminated to 2.5-foot candles average. We used existing and new utility poles, and we've installed lighting on the signal poles. The mounting heights vary. They are 25 feet and 45 feet, and they used a 309-watt LED Navion fixture in this case. These are all Tico lighting. Here's another location that was in, it wasn't in the top 20. However, this location had 2 pedestrian fatalities, school-age children. And this is what drove the improvement of lighting on Hillsborough Avenue. So in this case, originally the power company just looked at putting luminaires on existing poles that were out there. However, you can ask, and you may get an extra pole for no other purpose than to add the lighting. And here's a picture of that. This is day and night pictures of that same location with the LED lighting installed. It is illuminated to an average of 2.6-foot candles and uses the 309-watt Cooper Navion fixture at a 35-foot mounting height. This is Tico lighting in coordination with the department. This is a picture of another way to illuminate an intersection. We used a standalone DOT pole. The mast arms were already in place, and the lighting was added later. This is just down the road from the other one, and the luminaire is added to the signal pole. So this is a span wire signal with a luminaire. And the luminaire will be powered through the signal power source, which we're going to get into. So the DOT does not have a semi-standard for attaching a luminaire to a concrete or steel signal pole, but we have done it on recent projects. In this case, note number 2, which you probably can't read, requires the contractor to submit a shop drawing for the luminaire attachment. Super simple. You can get it done. A standard traffic signal power service drop was modified to provide power for intersection lighting. In this case, the power split in the traffic signal disconnect box. One goes to the traffic signal switch, and then the other is routed to the lighting control cabinet, which is located in the back, in this case, and it contains the circuit breakers for the lighting and the photoelectric switch for the lighting. This is not the only way to manage this, but it is a way. And it also is a way to keep it where it's pretty close to our standard index. Here's another interesting solution for lighting. This is on a county road, Fletcher, and it's a county project, but it's very innovative and is worthy of discussion. The mid-block crosswalks have luminaires that are push-button activated. You can see the little sign. It's definitely a special sign, and the lights are in the middle. This is the same intersection in daylight and nighttime when the flashers and street lights have been activated. I checked the original analysis report, and in the study they had 5-foot candles illumination and at a mounting height of 20 feet, and they used solar-powered 90-watt LED luminaires. Now, I'll have to say the report said there was lights on the mast arms and in the middle, and I can't remember if we did have the extra 2 lights. So 5-foot candles is a lot. This is the same intersection before and after the push button is activated. You can see in the dark one, well, you can't see, but Bill is standing there. When he pushes the button, there's bollards out there, so he's kind of hiding behind there, but I will have to say that the drivers actually stopped for us to cross in the mid-block crossing. This is just a slide I added in because I just had a recent request from a designer. So in case other people have the same question, I thought I would put it out there. So the question concerned a pay item. So when you use the high mass light pole pay item complete, you do need to use the light pole cable distribution system. Those pay items work together. I think there were some old notes and maybe the old specs that indicated something different, but this is appropriate. Both are needed. So in summary, lighting, and especially intersection lighting, can be challenging. It requires a lot of coordination with the agencies. Keep in mind that intersections may involve more than one agency. From personal experience, I have learned this. So it depends on if the signal maintainers will be maintaining the lighting or not. You may have one corner that's in the city limits and the other 3 corners in the county. Coordination is key. There's no one answer for what the right solution is. We're not locked into one voltage. However, we do need to coordinate with our locals, and they may have different concerns that need to be addressed. When you're designing a new system, a new corridor system, please design LED. We do have multiple brands that do meet DOT standard.
Rochelle, with regards to the LED, it looks like on Fletcher, there's a mix of high-pressure sodium and LED. Is it okay, like in an interim as projects are rolling out and there's overlap, and what's the guidance on mixing?
Well, I cheated a bit. The guidance is we prefer not to mix. However, I was given a time frame of 2 months or 3 months. In that case, we do know that the power companies are all switching over to LED, so I know that others will eventually get switched over. But you are correct, it is mixed. What can I say? I cheated. So
it's not disallowed to mix, but it's preferred not to.
It is definitely preferred not to, and I will say if the situation arises, then we need to have a discussion, and we will do what is best for the citizens of Florida. And the answer may vary. So this is our thank you. We had help from many sources. We had Chester Henson, the state traffic standards engineer, help us, and we did use many of our sources. So thank you to all of them. And do we have any other questions?
All the questions in the chat thus far have been answered. I didn't type the answer to what is the recommended foot candle lighting for an intersection. I don't know if you want to re-say that. I know that the intersection standard is higher than the corridor standard. I don't recall what the number is. That's a question that's in the chat that was...
Well, it isn't official yet. Right now we have the standards we have. We are going to higher standards, and it will be 3-foot candles. And these will be at intersections with high pedestrian traffic. So right now, I have been trying to get at least a minimum 1.5-foot candles everywhere, which, as you can see from what we've gotten, it's probably closer to 2.5 average. It seems to be working pretty good.
There's a question about the traditional sort of old method of collecting data out in the field. Do you want to talk about? You talked about the lighting measurement tools and going out and the what the process is for collecting that information when you're not using Cutter's newfangled way of doing it.
There has not been a systematic way or any method to go back and revisit our lighting. In general, the lighting has been installed and then it's been passed to maintenance. That we are looking at it now is new. The Cutter method is new, and we've also just gone out there ourselves with a light meter in the dark, alone, maybe not alone, and just measured it at the edge, the center of the road, and at the other edge. Just getting 2 or 3 spots in a crosswalk. We've done that recently for trying to identify safety needs. But
I don't want to misspeak about the actual standards, William, but I think that it's a 5-foot height, and it's at certain locations. With a handheld photometer is basically the way that it's done. It's time consuming and cost, and not, it's just time consuming because you need to go out and take measurements by hand in a lot of locations. What Cutter did basically was they used Fletcher as a test bed. They went out and collected the data for a large stretch of it by hand using those whatever the standard is, the 5-foot, at the curb line, in the middle, in the median, at the prescribed locations, and then they calibrated the vehicle so that they get an equivalent 5-foot reading foot candle, because the sensor on the car sits a little bit higher because it's kind of attached to the roof of the car, so that they were able to calculate their photometer in order to replicate the numbers that you would get if you were to walk the corridor and do it by hand. Give it a few minutes here. There's one more question in the chat. When I get a copy of the presentation, absolutely. The presentation will be posted on it's already actually there, the Tampa Bay Traffic Safety site. I will also add it right now to the webinar as a handout. I have a PDF of it that I can add, so you should be able to download it right from the webinar itself. Let's see. That's uploading right now, so that should. I'm not sure what it looks like as an attendee, but you should have a section for handouts, and the actual PDF of this presentation is uploaded right there. So if you'd like to download it, you can do that now. The PDH request form is there as well. This was a pretty informative presentation, Rochelle. Just so you know, this is actually the first time since we've been doing the webinar that we hit our upper limit on our number of attendees. We don't have a limit on the number of people that register, and I believe we have about 130 typically that register for this. And our current webinar license allows for 100 seats, and about halfway into the presentation that actually filled up. So you get to take the trophy home for being the first person to fill up our webinar. We may need to upgrade our account here to allow for more users if this trend continues. It's good. I mean, the Safety Academy is very useful, and I think that word is getting out, and people are, people are logging in and enjoying it. I don't know if any of the usual suspects, I can unmute Rudy, or I think Traffic Ops Peter already disconnected. But if anybody has anything that they want to add, if there's no other questions in the chat, I suppose I can end the recording here, and we'll stay on the line. If there's anybody that would like to be unmuted, we can chat. We'll stay on the line for a second to see if there's any other questions. But thank you for attending. I'll go ahead and end the recording.